Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In the previous couple of video tutorials, we focused specifically on the Dynamic World Dataset, and we're looking at creating images or visual representations of the land use, land cover for my particular region of interest. And we distinguish between 9 classes or 9 categories of land use, land cover, including bare soil, water, built up trees, etc., etc. And those are all available on the landing page of the Dynamic World Dataset. And one of the video tutorials that we did, we specifically created a visual interpretation or visually detecting the change in land use, land cover for my region of interest, and we created the split screen image so that we can visually, as I said, compare the two images or the two periods, and then identifying or detecting change in land use, land cover. So for example, we identified this particular area here. You can see there quite a bit of change in land use, land cover, and in particular in terms of the build up land use or land cover, that class or category of land use, land cover. You can see that clearly there. It's bare soil and vegetation, and now there's build up. And this is a recent seaside development that has been developed there. I think it's in 2019 it started there. And then another area that we identified is this informal settlement little here. You can see there's nothing there, and there's something there. So we've identified visually these two areas or locations within my region of interest that recorded significant change in land use, land cover. Okay, you can also see there's trees there, etc., etc. Anyway, so what I'm interested in doing now is to say, okay, let's only focus on, in our case, build-up areas. And again, you can use other classes, but let's just look at the build-up area and identify areas that have recorded or where there was now a significant increase in build-up footprint. So there was no build-up area there, and now there's a build-up area. So that's the only locations that I'm interested in. If there was build-up and there's still build-up, I'm not interested in it. It was nothing and nothing, I'm not interested. I'm only interested in where there was locations within my region of interest where there was bare soil or water or trees or whatever the case might be. There was no build-up, and now there's build-up. So that's what I'm interested in looking at. Okay, so this is what I'm going to generate. I'm just going to generate an image for my region of interest. Oops, a bit too much. I'm going to create the image of my region of interest. Let's just delete these ones here. I'm going to create the image of my region of interest, and in red it will indicate those locations within my region of interest. Remember, there's my region of interest quickly. It's going still okay. So while it's loading that specific layer, I'm only interested in locations within my region. Okay, there's my region of interest. Let's just take it off again. In my region of interest where there was an increase in build up, meaning there was nothing and now there's something. And so this is what the layer will look like. So the areas which are white, where there's no red colors, is where there's been no change in the built up footprint. Either there was built up areas and there still is, or there wasn't built up areas and there still aren't built up areas. So that's the two options. And so these red areas are locations within my region of interest where there were no build up, or the probability of that being built up was very, very low, meaning almost certainty there was no build up. And now in 2023, or whatever the time period is, there's built up. Okay, so that's what we're visualizing here. Okay, so let's see how we're going to do this. Okay, so as I said, it's a change detection using the probability bands. Remember, within the dynamic world, if I go to the dynamic world images, it doesn't give you 100%, that is the class of land use or land cover. It gives you a probability distribution. Remember, if we click on a specific location with our inspector, it will give you all the classes and it will give you a probability distribution. So what we're doing in Dynamic World is to say, okay, let's use this probability distribution, meaning if there was below a certain amount, we assume there was nothing, and if it's above a certain percentage, we assume there's something, whether it's 10% or 20% or 30%. It doesn't matter. What we're going to say is, if the probability is, and let's assume 10%, less than 10%, then there's nothing. So even if there's a 1% chance that there is a build-up, we still assume that there's nothing. And then we say, okay, give me 60% confidence that there is build-up. So if it's less than 60% confidence or probability, then we assume there's no build-up. If it's more than 60%, for example, then we assume there's build-up. So we don't have to say 100% confidence. We can say 60 or 70. So in this case, if we say less than 10%, in this particular area, you'll see less than 10%. If we look at build-up, where's build-up there? So in our case, there's no build-up there. So because it's less than 10%. Okay. So that's what we're saying here, is that we're working with the probability bands. Okay. So we're detecting. So the first port of call is to specify our beginning period, and our two periods that we're going to compare, our temporal detection period. Okay, so we're going to say, okay, I want to look at 2016, roughly to the 2016 period, and I want to look at the 2022 period. Now, remember, this database is available. If you go to the Dynamic World Dataset, it's available from 2015 to now 2024, but 2023. Okay, so I'm using 2016 and I'm using 2023. Why? Because each of these periods will have a starting date and an end date. So I'm not saying 2016 and 2022 per se. I'm saying around 2016 and around 2022. It could be a little bit before 2016, a little bit after 2016, because we don't know where the images are. We don't know what the images are, and we're working with years, not with months or quarters. So we're saying in this particular code, this is what we're saying here, is that we're saying, okay, let's look at the images around the year, 1 year before my before year and 1 year after my before year. So that's a beginning period and an end period centered around my before period. Okay, so I've got a start date and an end date, and all I'm saying is, okay, I want to look at 2016, I want to look at the period 1 year before 2016 and 1 year after 2016, and that is what we're saying here. So there's my before year 2016, and then I'm saying I'm looking at my before year one period, and it's in years, not in days or whatever. So one period in 1 year. Okay, so that means 2015. Okay, and then I'm going to say before end is going to be this before year, okay, or this before period here, and I'm advancing 1 year. So that gives me 2016. So I'm looking roughly at 2015 and 2016 as my before year. So my before year will have a beginning period and an end period. So I'm not looking just at 2016, I'm looking at a period around 2016. Okay, this is what I'm specifying here. So that gives me a number of images. So it's going to create an image collection, not one particular image, but a number of images, whether it's 10 images or 15 images or whatever the case might be. Okay, and I'm doing the same with my end period, which is 2022. So in this case, I'm looking at my after year. Okay, that's there. This is after year, and I'm saying it. Look at it as in one period, and those periods are in years. Remember, a period can be in a week, month, days, whatever. I'm looking at one period for 1 year. So that will be my start date for the 2022 period, and I will advance it by one period, meaning a year, to my end date for my after year. Okay, so I hope that makes sense. So I'm saying I want to look at 2016 and I want to look at 2022. Okay, we can make that 2023 as well, because it's advancing by 1 year. So that automatically takes you to 2023. Okay, so I'm looking roughly at 2015 and 2016. here, roughly 2015, 2016, and here I'm roughly looking at 2022 and 2023, because that's what we say. So we're giving it a time frame around my beginning period and a time frame around my end period. Now, you can change it, doesn't have to be like this. That's up to you. You can amend these days. You can just, you know, change that if you want to. Okay, so anyway, so and because we can create multiple, because there's multiple images in our beginning period and multiple images in our ending period, we want to use a statistic to generate one image, similar to what we've done in previous video tutorials, okay, where we create an image. There's an image collection, let's say of 12 images. We want to generate one image, so we take the 12 and say, okay, let's use the mean statistic, or let's use the median or the sum statistic to generate that one image. And this is what we're doing here with these two. We're generating one image for my before period, and we're generating one image for my after period. Okay, and those mean statistics there are based on all the images within this start date and end date for each of my two periods. Whenever that is, let's say that is 10 images there, it will generate a mean image from those 10 images. So that will be then my mean image for my before period, that's roughly 2016. And then I generate the same, a mean image for my post period, my 2022-2023 period. Okay, so that is basically what we're doing here. Okay, so I'm generating two images for my beginning period and my end period based on my time frames for each of those two periods. Okay, and obviously I'm using the Dynamic World Dataset clipped to my region of interest, and I'm specifically focusing on the built band. Now, just if we go to the dynamic world, remember there's our bands, and I'm specifically focusing on the built band. See that one there? That's the basically, see, you can use it for the others as well. There's the bands for the others as well. Okay, so back to this. So within my image collection, see, that's the image collection. Generate all the images for that period, generate all the images for that period, and then apply a mean statistic to generate one image, which we call my before image and my after image. Okay, so now I've got two images for the dynamic world. So what I want to do now is to generate within my before image. Okay, I want to identify all the areas that had no build up. Okay, remember, less than a certain percentage, because there's a probability distribution. And then I want to generate in my post video all the areas that have built up. Then I want to compare those two and identify those areas that didn't have build up before and now has built up. Okay, not areas where they weren't and there still isn't build up, or there was build up but now they still build up. I want to exclude those areas. So all I'm interested is to go and say, okay, in my before period, what was the areas that had no build up? Okay, and then my post periods, what was the areas that had build up that didn't have build up in the initial period? And remember, because I'm working with probability distributions, I have to allocate the probability distribution, work on probability. So in my case, I'm saying the before image, identify those areas that had no build up at 20% probability. Okay, so if it had a 30% probability, then obviously that areas will be assumed as having a build up. So it has to have a probability of less than 20%. So any location within my region of interest that had a probability of less than 20% probability of build up will be included, meaning, so this area here would be included because it was less than 20%. So what let's say this area here, let's okay, so let's go to this particular. Okay, so that was one of the areas that we've identified. So if we look at this particular area there, which I've just identified, that would be included because it had only a 6% chance of probability of build up. So that would be included. So that area there would have been included in this part here. Okay, so I can change that and make it 0.07, and that area would be included. As soon as I go less than that, let's say 2%, then that area will be excluded from my analysis. Okay, so in this case, I'm using 20%. And then I'm saying, okay, after it must be more than 50%. Okay, so therefore, after now, if I put the after, if I go there 2023, let's quickly do that. You can see there, let's do 2023 and 2023, and I run it. It's going to take a bit of time, but let's quickly just do this. Let's make it, see if we can speed it up a bit. If I go there, it's roughly, oopsie, no, it's not gonna, why is it giving me a red? It shouldn't give me a red. Classified image. Okay, so okay, so there's no, so let's just make that 30. And let's make that 1. Okay, so yeah, it's, I don't know whether there's images for that. That's why it's, let's see if it works now. There might not be Lancet images for that period. Okay, it looks like there may be. So while we're waiting for that, okay, so that's what we're doing in this case, is we're specifying our criteria for periods not to have any build-up, and for periods that did have build-up, and obviously that will be then our red areas. And then we simply just create a visualization parameter. Okay, it will be between 0% and 100%, and it's white is if there's 0, and red if it's white. We clip it and we display it, and this is basically what we're getting here. This is what this is all about. So let's just go back. Okay, so let's click on that one. You'll see there it will now have more than 50%. You see that? Remember, it was 0.06, now it's 0.73. So it was less than 6% chance that there was a build-up. Now there's more than 73% chance that there's build-up. So that would typically be now included here. That would be this place. If I press there, you'll see there, it will either give me, it will give me a 1. Okay, so that means 100% chance or 100% probability that there weren't any, based on our 20% and 50%, that there weren't any build-up structures. Now there's a build-up footprint. Okay, so that's what we're basically doing there, and then we're just displaying. Now this is basically just creating the Sentinel images to confirm those results. So nothing strange here. We're going into our normal Sentinel images, S2, 35% cloud cover, less than 35% for both our regions. And again, here we're calculating a medium image. Here we're going mean. Ideally, you should have a mean and a mean, but anyway, it shouldn't be too much of an issue and stuff. And basically, we're just creating those images also before and after for the similar period. So there's our Lancet before, and let's just also activate our Lancet after. Okay, so there's our Lancet before. You see there, there's nothing there, no build up there. Look there, there's also no, let's make it a bit bigger. Let's include it here. I don't know why it's so slow again this morning. There. Let's just wait. You'll see. Okay, there. Okay, so let's just go back here. You see there? You can clearly see there, no change there. You can see there. And if I go into the, this is the Lancet 2016 period. Remember that median period of around 2016, which has a start date and an end date. You can see there's nothing there. Clearly you can see there's nothing there. Now what's being loaded over that is the 2022, 23, that medium image. You can see there's build up. And so this is what, yeah, you can see this as well. If I just after it, you can see there, nothing there, and there's something there. And if I overlay my dynamic world layer that only focuses on the build-up area, you can see that one there, and it's obviously now I can also display this area. So it's quite a neat way of isolating a change in land use, land cover for my period, for my two distinct periods. Okay, and in this case we're looking at only build up, but you can change it to the other classes as well. Okay, you can change it to the other classes as well. So that's quite a neat way of isolating the change in a particular class of land use, land cover for my region of interest for my specified periods. Now again, you can play around with the periods. You can make it less, you can make it more, you can isolate a particular. So all of these things you can play around with. If you're not interested in having such a wide time frame for your beginning and your end period, you want to narrow it to a particular image or specific date, you can do that. If you want to look at other classes of land use, land cover, you can do that. So that gives you a nice room for maneuver or room for playing around for your analysis between the different classes of land use, land cover. Okay, so I hope you enjoyed this. Quite a neat little piece of analysis that you can perform for your region of interest. And it adds up to what we've done previously is in terms of change detection, visually presenting land use, land cover, creating a time series, quantifying the land use, land cover changes and parameters, etc., etc. So it's quite a neat little data set to work with, and it's called, as I said, Dynamic World, which is built upon the Sentinel 2 daytime images. Okay, so yeah, quite neat, interesting stuff. Play around with it and see what happens. There's some interesting things that you can do. Okay, so yeah, thanks for joining me on this remote sensing journey. I appreciate your company. Otherwise, it would be a very lonely journey. So thanks for being with me. As I said, you're more than welcome to make contact. I'm not the boffin on these things. I'm also on this journey of learning and experimenting and finding my way in the dark, so to speak. But it's fascinating. So thank you for joining me again. I hope you will continue to join me on this journey of remote sensing. Please remember to like, subscribe, and to share the video. And as I always say, oh yeah, before I say save and run, remember save and run, save and run, save and run, save and run. And then I'll see you on the other side.